As you can see from this opening slide, today's lesson is from section 813 of the CPM book, and they titled this Factoring with Special Cases, or How Can I Factor This? We're going to focus on problems 825 and 826 in order to meet our learning targets. So our learning targets are right here. So first of all, we're going to be reviewing factoring trinomials with both the diamond and rectangle method and the chart method. We'll look at a few examples that don't match the standard form of a quadratic expression, and the standard form is ax squared plus bx plus c. And then I'm going to give you an introduction to factoring out a monomial and factoring completely. Okay, so problem 825 is 9x squared minus 4. And as you can see by looking at this problem, we're missing the middle term. So that would be the b. All right, so one thing we could do to solve this is we could actually add a middle term of 0x. I said minus 0x. It doesn't matter if that's adding or subtracting, because either way, that's going to be 0, right? And then let's take a look at this. Okay, so I've already set up my diamond and my generic rectangle, so obviously I'm going to do that this way. So first step is to get your first and third terms into the rectangle, right? And then go ahead and set up your diamond. So we're looking for the product of the first and third, so that's negative 36x squared. And then where it really didn't matter whether 0 was positive or negative, I just put it in as 0x over here. So we're looking for factors that when added together give you a 0. Well, I bet you can figure out already what those would be. So 6x and negative 6x would be your terms, and then you can put them anywhere you'd like on the generic rectangle. All right, so then last step is to figure out your length and width of the generic rectangle. I started right here with a 3x, so I found this one first, and then from there I was able to go a little further. So this one also would be 3x. All right, so let's take a look at what I decided on. So right here then, when I factored this, I end up with 3x minus 2 times 3x plus 2. Interesting pattern, isn't it? So you can see right here, when it's written out as the product of two binomials, there's a little pattern here. So if we're thinking about this as multiplication, when you're doing your distributive property, you have 3x times negative 2, that's going to be negative 6x. But when you do 2 times 3x, that's positive 6x. You can see then that what's going to happen is the middle term is going to be basically wiped out because they'll be opposites. All right, so I found this slide on a website called Math Online. And I think this makes it really clear the special pattern we're talking about here. This is referred to in algebra as the difference of two squares, and sometimes you see it abbreviated dots. So it's basically taking a binomial a plus b and then multiplying it by the same thing, except that this second term here is the opposite sign, right? And you can see what happens when you do this. Right, so we have 3x plus 2 times 3x minus 2. It's funny how that was the exact same one. If we were to actually distribute everything, it would be 9x squared minus 6x plus 6x minus 4. Well, the positive 6x and the negative 6x would cancel each other out, so you just end up with 9x squared minus 4. So the real quick thing you can do once you start to recognize that, oh, that's a difference of two squares, when you're multiplying, all you need to do is square the first term. Well, I shouldn't say square. You multiply the first terms and the last terms. You can just ignore the middle terms because they're just going to wipe each other out. And you can get pretty quick at factoring this as well, because then you know it's really the square root of this one. And then it's find the square root of this one, but add it in one and subtract it in another. All right, we'll talk about this one later, but I just want to point out, interesting. They factored out a 3 first, right? So if you take a look at this, this is called factoring out a monomial. We're going to talk about that in another slide. But this x squared minus 25, that's actually a difference of two squares. That's x plus 5 times x minus 5. Right, so I hope that makes sense. That's going to be x squared, the 5x would cancel out the negative 5x, and then you'd have negative 25. All right, so that's the first pattern we're going to talk about. Okay, so the next problem in 825 is 12x squared minus 16x. So one way we could approach this is by doing what we did in the last situation, and you can see what's happening is we're missing the c term. All right, but let's see what happens when we replace c with 0 when we try to factor it. Okay, so I've done the generic rectangle. All right, so here's my first term, here's the third term. Right here, product of the first and third, that's 0. And then the sum here is negative 16x. All right, I think you can see right away that we've got a problem, all right, because what happens is we're trying to look for factors of 0 that will give a sum of negative 16. There's nothing that will give that to us, all right? So if we are missing this last term, that is not the way to factor this problem. All right, so the way to factor this one is what I was just talking to you about. In this situation, what we can do is factor out a monomial. Now remember, a monomial has just one term. Here's how you do that. What you're going to look for is the greatest common factor for these two terms. So I always start with the number. What is the largest number that goes into 12 and 16? All right, I'm not going to worry about this negative right now. I'm just going to worry about these terms. All right, so the greatest number that goes into both of those is 4. All right, so part of my monomial is going to be 4. And then I also look at my x's. All right, if I have variables in both, easiest thing to do is find the variable with the lowest exponent. Well, that's going to be this one right here. So I can divide out a 4 and I can divide out an x from both of these. So that means my greatest common factor for these is 4x. All right, so then what I do is divide both of these by 4x, and then I can get, then basically I've factored out the monomial. So what I do is I write my greatest common factor first, and then I set up my parentheses. Right, then I basically go here, and I start with the number first, so 12 divided by 4 is 3, and then x squared divided by x is x. So then 12x squared divided by 4x is 3x. And then I have my negative 16. I'm going to divide that by 4, so that's negative 4. And since this already is an x, that's just going to become 1. So when I divide 12x squared minus 16x by 4x, it becomes 3x minus 4. I can double check that real quickly by using distributive property. So really think about this factoring as division. So I can multiply to see if I did it right. Sure enough, that's 12x squared minus 16x. That's called factoring out a monomial. All right, you just did it. Okay, let's take a look next at letter C in 825. And you can see I've already decided I'd like to try the chart method on this one. Okay, so I'm looking at this. It's like that has all of the proper parts, right? So how would we solve that? Okay, so I think the thing that makes the most sense here is to just write them in order, and then we'll go from there. All right, so you can see what I did here is I just switched this around to 8k squared minus 10k plus 3. That is the very same value as this. This, by the way, is considered proper mathematical form, written in descending order of exponents. That means the variable with the highest exponent is first. So this really is the best way to write it. All right, so you can see I decided to use the chart method here. So on the top of it, I've got factors of my first term, k and 8k, and then 2k and 4k. And then down here, I have factors of my third term. In this case, I'm looking for a sum, because remember that's a positive, of negative 10. Right, so I can go this way. So this way would be 8k, 3, no, that's 11k. Let's try this way, 2k, that's 6k. That is going to be 10. And so since I want it to be negative 10, then both the 1 and the 3 would be negative. All right, so here I have written my patterns. I didn't put the negatives in here, but I knew down here to make them both negative. So I decided the 2k and the negative 3 would be my outers, and the 4k and the negative 1 would be my inners. All right, so all that had to happen on this one is it needed to be written in the correct order so that it matched the standard form for the quadratic expression. All right, problem D, this is the last problem from 825. All right, so let's take a look at this one. We've got 40 minus 100m. Okay, so I think you can see what I did here. I just put in the first term as 0 times m squared just to try to make it match the form, because that would be 0, so it wouldn't change the value, minus 100m plus 40. But if you take a look over here, I think even doing the chart method, you can see this is kind of similar to the one we did before, where we put in a 0 and it just made things really hard. So this is all I can do for the factors of 0. Down here I have the factors of 40. I think you can see how I've arranged that. So 1 and 40, 2 and 23 doesn't go in, 4 and 10, 5 and 8, 6 doesn't, 7 doesn't, then we're back to 8. So I know this would be all of the whole number factors for 40. Right, but when I'm multiplying, the only thing I can get here is 0. So I cannot get negative 100m. So I can't actually do this way. So what we're going to do with this one is just what we did before. We're going to factor out a monomial. So I think you can see from this case, the greatest common factor is 20. And there is no variable in the greatest common factor because there's no variable here. So same thing, you figure out the greatest common factor, what's the largest number that will go into both. And then since it was 20, you write that on the outside of the parentheses. Then 40 divided by 20 is 2. And then minus, and then 100m divided by 20 is 5m. You could also think about this as a negative 100m divided by 20 is negative 5m. But then to double check, just use distributive property. 20 times 2 is 40. 20 times negative 5m is negative 100m. That's it. All right, so this is how you factor a situation like that. Start by factoring out a monomial. All right, we're now going to look at problem 826. And I think you can see here that I have drawn two different diamond rectangle situations. All right, there is a reason for that. Okay, so you can see what I've done here is I went ahead and I set up my generic rectangles and my diamond, and you can see they both look the same. So first and third terms, product of the first and third, looking for 10, and so the combination there is 2x and negative 12x, so then I just wrote them here. All right, so again, but why the two tables? All right, so watch this next slide. Okay, so I think what you can see here is what happened when I figured out the factors of each side is that I got two different answers. I have 2x minus 6 times 2x plus 1 here, and then I have x minus 3 times 4x plus 2 down here. So both of those answers are correct, but remember I said I was going to actually introduce you to something called factoring completely. In this situation, neither of these is factored completely. All right, I'll explain that in just a second. Okay, so what I've done here is I took the two answers that we got from the slide where we did the diamond and rectangle, 2x minus 6 times 2x plus 1, and then the other answer was x minus 3 times 4x plus 2. And what I noticed is back to factoring out a monomial, I could factor out a 2 from this. So I went ahead and did that. So that would be 2 times x minus 3, and then this stays the same. And then over here, I figured I could factor a 2 out of this. So I did that, and I wrote the 2 first. I kept x minus 3 the same, but then when I factored the 2 out of that, it became 2x plus 1. I think you can then see by looking at these, those are the same answer. This is what we call factored completely. So everything here is what we would call prime in terms of algebra. I think it's best though if you factor out the monomial first. So I'll show you what that looks like. So you can see here, what I did is factor out the 2 first, and that means I just need to factor this. I set up my diamond in my table, and here's what I've got. All right, awesome job on this.